paracetamol using the embossment protranostate and selling it. Is that not criminal? You won't be able to tell. You test for the antimicrobial agents, not there. But then you have the whole list. You go and start testing what I want. When you get to paracetamol, you know that it was paracetamol actually he used. But then he used the punches and dyes to introduce it. Criminal. In non-pharmacies, try to control a pharmacy and influence the pharmacies on that kind of work. People who have infection, then they prescribe for them, and all they take is paracetamol. The infection will not go. So it's doable, but it's an expensive one. It's compared to things like impurity profile. Write that down. You can check it for impurity profile, and it's one of the most expensive analyses because you have too many unknowns. I don't know whether that's so that you don't think you have it. We're walking through it, and then if I announce it tomorrow, I was thinking today, give you the assignment and but if you take your notes and you do what you're taking, if I'm too fast, tell me I'll slow down, right? I want you to do it, not. I can give you the slides, it doesn't really make any sense to you, but I will not achieve what I want to achieve. So first on the list there is salicylates. I told you aspirin is what? Salicylate. Okay? So it's the salt of it. Now once you have a salicylate, the reagent test uses the ferric chloride solution. And the color you have for identity is a violet. For phenols, and I told you about phenols and paracetamol. So you apply again for a ferric chloride solution. You can have a blue color, green, or violet, or this thickness of the phenol, the concentration. That's why there's this different colors. Reducing sugars, aldehydes, present solution, brick red, precipitate, silver mirror color. What does that say? We have silver mirror.
Specific test.
This application, as you did it at 200.
Specific test for alkalis. You distinguish between alkalis and alkanos.
And then sugars. Alkaloids, drag it down from here to here. There's a color change. Chlorides, so limit test. Glass silver nitrate, of course you have a precipitate. Dilute nitric acid, white body precipitate, which is soluble in aluminum. barbituric drugs, cobalt reagent, gives you a violet blue color. So these are examples of chemical identity tests. Remember, we are doing non-instrumental. When we go to instrumental, we'll be talking of infrared, FTIR, particular. I'm not big enough. Okay. Okay, I'm moving on now to melting point. Okay, I'll go back a bit. No moment, you have a question.
Positive response for attitude.
Oh, it's you can see it. This is bucket. What is this? Violet blue color. Violet blue color. This. Is it okay now? Can you see?
Yes.
So that has been happening there.
No, that's what this
But this one is sitting right on it. Melting point or any question? Melting point is 6 point apart. It's also relatively cheap. But yet very, very critical. If you have mixtures that do not contain the things in the right composition, the melting point will never be the same as that of the standard. I'm sure you're aware of that. So it's a good, simple, straightforward test. First is capillary tube method, and then the significance of the pure crystalline will melt with a sharp melting point. So when you have a long range, some melting points have a range, but if it goes beyond that range, it is no longer. Sample with authentic reference, usually when in doubt, you may need an authentic sample to compare with your sample. This is straightforward. Boiling point, similar way. When sometimes we talk about this, they are not classified strictly as instruments, but apparatus in the lab. So, before one of you take me up and say we're talking of non-instrumental, and we're using melting point, we're using refractive index, we're using melting point apparatus, which you can improvise by just using test tubes, heaters, to achieve that. Refractive index. What is refractive index? We're coming across it over and over. One of the simplest equipment from simple physics. If you have, for example, you have water from the tap running through, that's the change in the refractive index, and then you bring in water from the River. That will definitely be different. Because with the composition is different. The composition determines the refractive index of change in angle of refraction that's defined because of the purity. So you can use it as basic for the technical physical constants. gravity, optical rotation, like sugars and all that, calorimeter is available, but you cannot really provide, so we look at them at this level as simple apparatuses for chiral. Why is chiral analysis important for drugs? They're doing from a common indicator.
Analysis is important for drug that we know the specific molecule, whether it is negative or negative, because there are some drugs that the negative component of it that is active in the body. And
The other is completely inactive. And when you have them in solid form, if somebody wants to cheat, and just go ahead and compound those ones for you. That is completely inactive. And the price of that will be 5 naira. The active one will be 5,000 or 10,000 naira per gram kilogram. So it's cheating to make money. So you need to quickly look at the rotation and know whether it's possible. I think the simple example, even though the drug no longer exists, is chloramphenicol. So if you go as an analyst, I want to analyze the chemical content of chloramphenicol capsules. I'll find it. If I send it to the microbiologist, if it's the inactive one, it will, none of there will be no sensitivity to any of the microbes. But instead of doing that, if I check the chirality using the rotation, I'll know that this one has a non-active so in analysis, that's important. Specific gravity ratio, micromolar ratio, is still important because if it misses it, it's not a substance. We know specific gravity physics. Yeah, but what you see specific gravity bottom. In physics, 100 you go into it. Okay, Google it and see the picture. Literally weightless bottom, but it's glass. So you put all your fluid inside there to the weight, and then it's the ratio you take. It's a specific gravity bottom. You'll see it's quite tiny. We have one here, but just broken and took it and then weight, literally weightless. It's very small. Can you see the picture?
Yes, sir.
So that simple transfer is what you need. And then you can use a picometer, hygrometer, density meter. But we've seen hygrometers for battery. Is there a person using solar tubular battery? You've seen car battery.
Yes.
Have you been to a charger before? Somebody who charges battery. Even if it's motorcycle. You've not seen them with one instrument like this. They use pulling out the water. You press the rubber and it comes up there, they check the reading. That's a hygrometer. They have tiny ones for the lab, which this tubular batteries for solar. They have them on top of that. So that if the specific gravity drops, you know, battery drops. How do you sorry, let me. Okay, so they are useful. They help us to determine quickly whether the product we're dealing with is fake or genuine. We can also determine the quantity. All the other things we were looking at was qualitative, right? Quantitative aspect, using non-instrumental. And this is where your titrations come in, acid, aqueous titration, non-aqueous titration, acid base, complexometric titration, gravimetric titration, that help in determining the quantity. But without using instruments. We will be doing the one for instruments, I think, So again, there are contents in our monographs, specified in the monographs where you use. So they determine how much. It's not just the identity, the qualitative aspect, but how much. So if I give you a tablet, you can say contents of this tablet. This paracetamol from one tablet is 500 milligrams, right? Yes. So you will then determine is that correct? But in most cases, things like I went and left the market in the office. Some little I was carrying it. I left it.